Okay, can you guys hear us? I think we got a lot of messages saying
Yeah, we can hear you now. We can hear you, yeah.
Perfect. Looks like I have to repeat everything from the beginning now. All right. Thank you, Sanju. So I think I'll just go over the housekeeping tips really quick. This webinar is scheduled for an hour, including the Q&A. So you can always post your questions through the Q&A option that's available on the webinar. And we will have our panelists and other folks who are on the call respond back to you. We will also have time at the end of the webinar where you can ask your questions too. And this webinar is being recorded, so you will receive, all the registered participants will receive a link to the recording at the end of the webinar. And there will also be a survey link which will be posted to you at the end of the webinar. Please take a minute to fill in the survey and provide your feedback on this particular topic and any other future topics that you would like to hear from us. Finally, I wanted to call out the most recent release that we had, a Success Portal, which is our micro-learning platform, which offers unlimited learning opportunities for you to learn about a product, starting from the basic functionalities to the most advanced level. So these learning paths are free. Any number of people in your organization can learn, can access it, and this also includes a breadth of features and functionalities like the Tech Tuesday webinars, which is part of the Success Portal, an enriched onboarding experience for customers. It also has a chatbot integration, which will be coming up at the end of the month, and obviously the most popular learning path, which helps our customers to get to know about a product and learn the different features and functionalities. So as of now, we support 5 different products: MDM, Big Data, EDC, Axon, and IICS Cloud. So these are the 5 products where we provide the learning path for all the customers. Like I mentioned, it's free. It's a free training platform, and it provides foundational to advanced Informatica product knowledge. And all the topics that we present as part of the Tech Tuesday webinars will also be added to the learning path based on the level of expertise the content goes into. So I would encourage everyone to actually visit the Success Portal at success.informatica.com and explore the portal and provide your feedback so that we can always improve on what we have built on today. So with that, I'm going to turn it over to David. David, over to you. Thank you.
All right. This is a disclaimer. It's interesting, so let's not spend any time on it. So today's agenda in the webinar, we will look into MDM Best Practices, focusing on various performance parameters. As you all know, there is no one-size-fits-all solution for performance. There are a lot of variables to consider: the volume of the data, the server capacity, database capacity, and also it requires many iterations of testing to come up with an optimal configuration. Even after tuning, it needs to be monitored regularly. Also, you might have different configurations for the initial data load versus the deltas. This presentation is not an in-depth performance tuning exercise, as that has to be done on a case-by-case basis, but hopefully will help to save some time in the initial tuning of these parameters and also to reduce the number of test iterations. It is also a compilation of some of the common issues that have been reported over the years and some of the best practices to follow to avoid these issues. We will cover operational reference store, ORS level settings, database level settings, application server level settings, and thread settings for batch jobs, and also how to monitor and create reporting on batch jobs. This is mainly to compare historical data with respect to time and number of affected records. Also, batch job properties related to stage, load, tokenization, load, match, and merge. We will also cover best practices for Smart Search. In housekeeping, we will cover to generate the reports and, again, like I said, monitor the historical data. One final note before we proceed, the slides are more verbose than a typical presentation, but it was intentionally done, so if one chooses not to go through the presentation or the recording, they can read through the slides. So after best practices, register only in-use ORS, operating reference stores. This will shorten the restart time, because on restart, each and every ORS is validated. And also, the more objects you have in the ORS, the more time it takes to validate, and it also affects the metadata cache loading. So drop unwanted objects from development before the code promotion. MDM by default provides an authentication provider, and external providers like LDAP can be added. When a user logs into MDM, it iterates through each of these providers in the order listed. And when you view it from in the order listed when you view it from the Hub console, till it finds one that can authenticate the user. So if most logins are authenticated via, say, LDAP, then move the LDAP authentication provider to the top of the list. This again can be done on the Hub console. So because every API call will go through this process, and the quicker the user is authenticated, the better performance you get. A Security Access Manager, or SAM, is also a powerful tool to control user access. Avoid creating too many roles. This can cause performance issues. Also avoid using inherited roles when possible. It can lead to unexpected behavior. So, spend some time on granting privileges to roles. And use Hub Console for developing, and try not to use it for data stewards task. For merging or editing, use IDD or E360 instead. Batch execution can also be automated, and you don't have to rely on the Hub console. One other thing that affects performance, this is mostly ignored, is the logging levels. Debug logging levels can adversely affect performance. Set to info or error in production, or when performance benchmark tests are done. The logging levels can be set in the log4j.xml file, which is normally found in the conf directory in server or cleanse. We have seen instances where the file appender threshold was set to info, but the individual categories were set to debug. This will also cause performance issues, so it's important to set the individual categories in info or error mode. Auditing on the MDM also increases or rather slows down performance because it has an overhead. Use auditing only for debugging purposes. And database level archive logging, like if you're for initial data load, you can disable archive logging. This will, especially for large volume of data. Batch API interoperability is a flag that is used in environments where batch jobs and real-time calls should work at the same time. So there are some additional overheads related to batch API. Enable only if you are using both real-time and batches. If you're not using real-time batches, meaning at the same time or in parallel, then do not set this property. And during initial load, it is recommended to disable this property because some of the index maintenance don't have to be done. Essentially, like, for example, if you take a load job where you're loading 10 million records, the index will be dropped at the start of the job and created at the end of the job. So during the inserts of these, the indexes will no need to maintain the indexes. So in the next few slides, we will look into cache settings. MDM caches metadata as well as user profiles to avoid database round trips. Each API call will do a lookup on these caches, and if not cached, will adversely affect performance. Acquiring schema write lock will disable the metadata cache and will have a negative effect on performance. As I mentioned, the metadata has to be read from the database for each and every API call. So in production environment, when doing performance benchmark testing, enable the production mode All it does is it just prevents accidental acquiring of the schema write lock. That is, when a user tries to acquire a lock, a pop-up window will come in with a warning saying, production mode is on. Also in production, avoid taking locks on the master database or on the master schema, because some of the master schema metadata is also cached. For metadata caching, MDM internally uses Infinispan cache. We will look into Infinispan cache settings later on in the presentation. So we talked about user profile caching and metadata caching. So first, let's focus on the user profile cache. So the user profile cache and security access manager cache store the user's roles as well as what privileges are given to a role respectively. There are three relevant properties. The first one is this cache enabled? By default, it is enabled, so you don't have to change anything for that. But the other two properties is controls when the cache expires and how long each object stays in the cache. By default, the user profile cacheable, and the time to live or the lifespan is 1 minute. It is recommended to increase the lifespan and expiration in production. The downside is if you were to add a role or if you were to add a privilege to a role, it will wait for this, whatever setting is set, that's how long it will wait. But then normally in production environments, you don't make these changes often, so we would recommend setting production for 1 hour. But if in the environment there's a requirement to change privileges and roles, then the recommendation is not set it to a higher value. So we looked into metadata cache a couple of slides ago. MDM, again, internally uses Infinispan cache for caching metadata, and also from 10.3 onwards, session management. It also caches search tokens. So the best practices for Infinispan configuration is try to use unique ports per environment. This is to avoid overhead. Like even though messages, though rejected, if a message comes from a different environment, let's say development, it comes into the QA, the message will be rejected, but there is an overhead. The configuration files for Infinispan are in hub server resources and cleanse resources. We will spend some time on the third bullet point, especially with the clustered environments. It is very important that Infinispan clustering is set and also it's replicated, mainly because of the session management. You can look in the server startup logs to see if there are any errors related to starting up the Infinispan cache, and you can raise a case if there are any errors. On a clustered multi-node environment, the Infinispan cache should form a cluster for it to be replicated. Why is this important? Let's take an example. As you mentioned, session management is also cached in this cache, right? So let's say you use a load balance URL to log into the IDD application. At login time, it logs into, say, node 1. It creates the session ID on node 1. The subsequent request using this session ID may go to node 2. And if the session ID is not replicated, then you will get an expired session, or you get a session will fail. So now that we've established in the multi-node clustered environment, replication is required, and for replication to happen, Infinispan clustering must be established. Let's look into how to make sure clustering happens across nodes. So only nodes with the same cache name or cluster name will be clustered and replicated. The cache name is formed using two parameters, I should say. One is from the CMX system C reports database host column, and the other one is the cluster name, which is specified in the Infinispan config.xml file. Normally, you don't modify the Infinispan cluster name on the Infinispan config XML. So the important thing to look here is the C repos database host. Make sure it is not set to localhost. If it is set to localhost, then it will, on multi-node environment, it will resolve to different IPs. This will be the IP of each of the application server that you have. Thus, the cluster name will be different, and there will be no replication. You can directly update this column in the database, and while updating, make sure you update it to a host name that is uniquely resolves to an IP address. Especially, if you're on a rack or the database is clustered, it's possible that the host name of the database could resolve to multiple IP addresses. So each node, again, possible to have different IP addresses. So in those cases, update this to a IP or a host name that is uniquely resolvable. There are a couple of KB articles there. Refer those articles. One for how to set up the Infinispan config XML, and also the lifespan. So this Infinispan cache will expire under two circumstances. One is when you acquire the schema write lock, and the other one, there is a configuration called lifespan for each cache. The default lifespan is 1 hour. In production, we recommend to increase it. We have customers who have set it for a month or weeks. So that's the recommendation for production, or when you're using performance and tuning, because when the cache expires, it has to be loaded, and if there are parallel, if multiple calls come in parallel, this will lead to each thread waiting on the cache to be loaded. If you want to get a bit more technical on this, if you want to test to see if the cache is replicated, as I mentioned, the search tokens are also cached. So you can use a SOAP call or API call, a search call against, say, node 1, and get the search token from the response, and then fire a get search results call on the other nodes. If that call fails, then you know replication is not happening. So this is what I mentioned, just to see the lifespan and the Infinispan cluster name, the two highlighted ones. Obviously, as I said, the cluster name, normally we don't change it, but if you change it, make sure on the same environment it is the same across the nodes. The lifespan by default, this is in milliseconds, so it's 1 hour. We look into the dynamic match analysis threshold. We will not be spending much time on it, but if you have a large range that can cause slowness, match slowness can be caused by data. There is a KB article which has a very in-depth explanation of how to find these ranges and how to set the DMAT. I would recommend you guys to please refer to that knowledge base article. Again, match tuning. When creating match rules, please keep the following in mind. Try to keep the matching on the process server. So matching in the process server is much faster, as it can take advantage of the parallel thread as well as multiple process servers if you have a multi-node system. Fuzzy rules are run on the process server. Exact rules are not. They are run against the database. It's a SQL query that is run against the database. And there's a third type of rule called filtered rules. So when possible, try to make exact rules as filtered rules. Example, if you have an exact rule on, say, person name and social security number, and if the person name is also your fuzzy key, create the rule as a fuzzy and select only the exact columns and save it. It will automatically be created as a match rule of type filtered. The filtered type rules will be processed in the process server. They will be essentially like a fuzzy rule. It will use multi-threading, and it will use the fuzzy key for the search. So when you, other best practices of ORS is try not to create your backup tables with a string starting with 3 repos, because that is the standard that the metadata tables are used, names are used. This degrades the hub console performance. High volume of data in some of the historical, in tables that, repository tables that stores historical data, best to do regular maintenance on these tables. Be careful when truncating the C reports job tables if raw retention is enabled. There is also a if you look at the line where it says C reports job control, there is a property called job control number of days. You can set this to let's say 1 month. What it does is it controls the display of historical batch job data on the hub console. So if you have years worth of data, then setting it to a week or a month will result in better performance when you go to the batch viewer. These are some of the task-related configuration parameters, which we will not spend any time on it. One thing you have to be aware of is the second last parameter, task creation maximum. By default, this is 50. If your requirement is to create more than 50 tasks, this property has to be added to the CMX server properties, and set it to an appropriate value, 1,000 or 2,000. In the next couple of slides, we will look into database and JVM parameters. As we mentioned at the start of the session, these are recommendations and may vary and will vary from implementation to implementation. We have a performance and tuning performance foundation guide in which there are recommended parameters for Oracle and DB2. The KB mentioned has the performance foundation guide. You try to use dedicated environment for database, at least for production. Obviously it helps with the performance, as well as when troubleshooting performance issues, we know, there are no contention due to other processes. Test IO is a utility that is shipped with the resource kit, which kind of is used to benchmark the IO response. We have done benchmarks using this utility, and so the numbers that you get from your environment can be compared with what we have to see whether it's optimal or not. It is also best to run this utility directly on the database server as well as from the application server. This is to test network-related slowness. As I mentioned, for database tuning parameters, please refer to the Performance Foundation Guide. For SQL Server, we are working on a plan to come up with recommendations. These are some of the parameters that we have come up with so far. SQL Server does do a lock promotion to a table lock after a transaction acquires 5,000 locks. This is the default setting. So if real-time calls are being blocked by batch jobs, you may want to increase or make it unlimited per table. Having mentioned that, we are also working on changing the SQL statements to work on smaller batches. A lot of batch statements do work on smaller batches, but some of the updates like consolidation indicators and those are not done in smaller batches. Parameterization forced will help to reuse of cached execution plans when literals are used in queries, and we do have queries that use literals. Again, these are Java JVM parameters. As I mentioned again, will vary from installation to installation. We recommend use minimum 4 gigs. And if you're using more than 6 gigs for XMX, use the G1GC garbage collection policy. Same for process server. As far as data source, number of data source connections or maximum data source connections, the recommendation is 2.5 times. the number of concurrent connections. So if you have 50 concurrent connections, it should be 125. For the CMX system data source, it's 1.5 times the number of concurrent connections. On the app server level, there are two other threads that we have seen causing issues. One is the async thread pool. For JBoss, the default is 10, but it's recommended to increase it to somewhere between 20 to 30. Same with EJB connection pool. Default value is 20, but recommendation is to increase to 50 if you're making a lot of EJB calls. For WebSphere, I would say for WebSphere and WebLogic, refer to the application server guides. WebSphere, I believe the async thread pool is configured under thread pools, and the EJB is configured in the default work manager. WebLogic, as far as I know, the default work manager cannot be configured, and you'll have to create custom work managers in order to set this up. Now let's look into MDM Job Properties. So in the next few slides, actually more than a few slides, we will look into the job properties. You can essentially group the jobs into two categories: the stage, tokenization, and match. These jobs use the legacy multi-threading and distribution. And the second category is the newer jobs, or what we changed since 9.7.1 when we went to the Java load, which is load, merge, recalculate BVT, etc. So each of these categories of jobs have their own set of configurations. The second category, which is the non-legacy distribution, have a configuration to limit the number of threads used per job, as well as there's a limit on the total number of threads jobs running in parallel can use. The second parameter is not there in the legacy multi-threading. So essentially, what this limit does is, let's say you have configured the load job to run with 10 parallel threads. So this is each load job can run in 10 parallel threads, and the maximum threads that can be used by all jobs is set to 30. Then you will be able to run 3 load jobs in parallel, each using 10 threads. If you try to run anything more than that, you will get an error saying not enough capacity. And some of these properties that we look into in the next slides, they are set on Hub Console, and some are set on the CMX server properties. And as you know, any changes to the properties file requires a restart. So first, let's look into the state job. State job uses the legacy, as we mentioned, the legacy multi-threading and distribution. Thread for cleanse operation controls how many parallel threads can be used for each state job. Our recommendation is to start number of CPUs -1. This is set on the Hub Console process server. Again, this property is also used by the match and also by the tokenization process. And there is on multi-node systems, state jobs, there is a property called the min size for distribution. Essentially what it means is MDM will distribute the cleanse job in multi-node environments if the state job has more than the number of records that is specified for this parameter. Default is 1000. This same parameter is also used by match. We will look into that. But for match distribution, there is an additional property that needs to be set. It's actually doesn't have to be set because the default is set to 1. The property is the distributed match. And again, as we talked about in the state job, there is a minimum size of records for distribution. Match job has another property, which is so when you're loading the data, the match data, in our older versions we used to use SQL loader or DB2 loader. Now you have an option to use the Java load. Java load is nothing but bunch of insert statements run in parallel. So you can set the CMX server match file load to true or false. Match has some additional properties that our recommendation is that you have to look into and set the maximum matches for manual consolidation. This is if you have a match rule set and you're running a match job, and if the manual rules come up with more than 1,000, the default value, the match job will stop. So you may want to increase this to whatever your requirement is. There is also the number of rows per match job cycle. So this is like if you have, example, 1 million rows, with the default setting, it will do 10 rows at a time, which is not optimal. I would recommend you to set this to 1 million and look into your performance. And the third parameter is the max elapsed match minutes. Essentially, the default is 20. After 20 minutes, the job will stop. So you will want to increase this to how long that you want it to be. The first two properties are set on the match settings on the Hub console. The last property is set on the base object advanced property. Now let's look into the tokenization job. Tokenization job also uses parallel threads, but is not distributed on multi-node environments, unlike stage and match jobs. As mentioned, the parallelism is again controlled by the threads for cleanse operations. I want to spend some time on understanding the tokenization job because we've seen that, especially when you run real-time and batch jobs in parallel, it is important to understand the tokenization job so we can set these parameters so that it won't cause blocking. So the first part we can break the tokenization job into two. The first part is the process server generates the tokens and it puts it into a temporary table. How it inserts into the temporary table, again, we saw is controlled by the file load, whether you want to use the SQL loader or DB2 loader or the Java load. For SQL Server, by default, Java load is used. Right. So now let's look into the first part of the thing. The first part of the tokenization job is to populate the temp table. The second part of the tokenization job is to insert whatever is in the temp table into the strip table, strp table, and which actually holds the tokens. So what we have now is we have two tables. One is the temp table and then the strp table. And there is an overlap of records between these two tables. Any updates that happened any records that were updated will be in both these tables. And any new inserts will only be in the temp table, and anything that was not changed will only be in the strip table. So the second part of the operation is to merge these two tables. One second. And the merging operation is done in two different ways. We can delete the change records from the strp table and insert what is in the temp table into the strp. Or we can insert the unchanged records from the strp table to the temp table. Which part the code chooses depends on the first two parameters on the slide, the strip CTAS delete ratio and delete upper limit. With the first option, where it deletes from the strip table and insert from temp table, the SQL is run with parallel threads, and you can also control the batch size. The second part, where unchanged records are inserted into the temp table from the strip table and then the name of the tables are changed, it's a single SQL statement and can cause blocking for real time. So, obviously, if batch API interoperability is not set, you don't have to worry about it because you're not running real time and batch job in parallel. And again, so if these two parameters, if the number of change records or the number of records being tokenized are less than these two parameters, or what these two parameters are set to, it will choose the optimal path, which will not result in the block. So it's out of the box, the theta's delete upper limit is 40,000. So if you have 1 million records, you've already, and if you have let's say 10% of the 1 million records is your delta, you've already passed it, and it's going to choose the non-optimal way of merging these records. So the rule of thumb is try to set the theta's upper limit to 10% of the number of records you have in the base object. There is also an additional property that would want to bring your attention to, is the use delete insert lock true. You can refer to the knowledge base article. Basically, we've seen instances where, as I mentioned, in the optimal way of doing, we delete the change records and then we insert the newly created ones. So at this time, there is a small interval where the real-time calls will come, and they might have, like IDD, for instance, if you've edited a record in IDD, and that might have created the token, so you will run into duplicate key issues. Again, refer to the KB for more details. Now let's. These are the threads that on the settings on this slide is the one that controls how many threads are used for this merging of the temp and strip tables. For the insert part, for the delete part, and the update part. Again, as I said, this will come into the picture only when the optimal way of merging these records are used. DB2 has a special parameter, the last one you see there, because on DB2 we found that deleting these temp, or rather dirty records, was not optimal. So instead of deleting, an update is used, and there is a daemon that you can configure which will go and delete the invalid records on the back end on a batch way. Like you can configure the sizes and how many deleted and how long you can delete those records. This is all you can refer to in the MDM configuration guide. Now that we've covered the legacy way of distributing jobs, which is the stage, tokenization, and match, let's go to the other category of jobs. Here also, as I mentioned, there is two parameters, right? One is how many threads can be used for each job. You can also configure the batch size of these jobs, and also you can cap the number of threads that can be used by any job that runs in parallel. So threads for batch processing is set via the hub console and sets the upper limit on the total number of threads used by non-legacy batch jobs that are run in parallel. Set this value to the number of parallel jobs that you will be running times the max threads per job divided by batch enabled process servers. So if you have 3 load jobs running with 10 threads with 2 process servers, set this to 16 because it says greater. Don't set it to 15, set it to a little higher than the actual number. If you have multiple process servers, then you can set this value on each one of them, and they can be different values also depending on each of the capacity. These properties control the individual jobs, so threads per job. Threads per job is a special parameter that is used by multiple jobs. It's used by load, recalculate, and revalidate. Almost all the other batch jobs have their own individual settings to control the threads per job. And then, like I said, there will be block sizes. We're running out of time. I think we're running out of time, so I'll try to speed up through this. So again, you can go through the slides, and it's pretty straightforward. Each job has its own block size, and you can set the thread size and the block size. The default block size is 250. Wouldn't recommend increasing that. In most cases, you don't have to increase that. One thing that I would bring your attention to is the third parameter from the bottom. Accept unmatched records as unique. This one, it is not set in the properties file. The default is 20, and so if in your case, if you don't have the global limit or the threads for batch processing, set to some value less than 20, you might want to increase this. You'll have to add this property to the cleanse properties and set it to an appropriate value, but lower value, I would say. AutoMerge job, since we are pressed for time, the only thing that we need to note here is by default it is set to 1, so you may want to increase this. And as I mentioned earlier, the last bullet says notes about the accept as unique number of threads. Unmerge, recalculate BVT, revalidation. So as I mentioned earlier, the recalculate BVT, revalidate batch jobs, they use the same setting that the load job uses, which is the threads per job. Recalculate, but the block sizes can be configured. Batch unmerge block size and batch unmerged thread size can also be configured. Let's look into Smart Search. Some settings that some of the things to keep in mind when doing Smart Search. Avoid enabling search on entities that have the same BO as the parent. This example would be party, right? Party, you have a party type of person and a party type of organization. If you create two business entities without a filter, like a person and an organization entity, but you don't say, party type is equal to person or party type is equal to organization, that is what will be configured as the same, same entity on the same BO. Try not to enable searches on these entities. Always keep index columns to a minimum required. Spend some time on finding, what users will be using to search. Let's not go and make all of them searchable. Search is automatically enabled on lookup columns on the BE level if search is enabled on the reference entity level. So for instance, example, country code, you want all the business entities to be, able to be searched on country code. Enable it on the reference level, and it will automatically be enabled on the business entities also. And if on the other side, if you want to disable it on one of the business entity, you'll have to modify the search config XML manually and update it. For performance impact, total searchable columns per operating ORS should be under 100. Try to keep searchable columns to less than 15 per business entity. And if possible, avoid configuring searchable columns at a depth of more than 4th or 5th level of children. While indexing the parent BO first. So a lookup BO is considered a parent BO, so ideal to create, it's best to index the lookup jobs. Also, we recommend to create index jobs as its own batch group, because, if you were to redo the initial index jobs, it's easy to run it via batch job instead of batch group, instead of going and searching and finding which all BOs are search enabled. Also, best to have a dedicated server for Elasticsearch, because Elasticsearch is heavy on read-write operations, so solid-state devices will also help. Initial indexing uses the same threads per job property. This is the same property that load job also uses, and controls the number of parallel threads. Avoid indexing uniquely identifiable columns. If you're using, for example, persistent ID, use database queries. They're much faster, and also for uniquely identifiable columns, it's much faster. But please note, you will have to create an index on these columns. Housekeeping. On this slide, we will look into monitoring on an ongoing basis, because over time, the volume of incoming records could change, or a source, we'll look into that later. So by monitoring the system like CPU, memory consumption, number of records being inserted, updated, merged, matched, It'll help you to troubleshoot and, prevent issues. Issues as in, like, say, for instance, you've got a new source and for some reason it sent you invalid data or had invalid this thing, and it resulted in a big cluster merging together, or then suddenly the number of merges have increased. So you might want to monitor that. Monitor the hub, the file system, especially the cleanse temp folder, where the temporary files that are used for stage, tokenization, match, and all kept. So you can set this property in your cleanse properties file to delete, which is the CMX server data layer cleanse working files, which will delete these files after the job completes. Or you can write your own scripts to maintain, like, keep 2 weeks worth of data or 1 week worth of data. So monitor. The next slide, we won't be talking much about it, but you can read through it. It gives you the column names and table names that you can use to form your own query to monitor the job performance. There is a sample query also at the end. So we are open for Q&A. We have about 10 minutes.
Thank you, David. So I know there are a lot of questions coming in through the Q&A channel. So if you have any other questions, please post it in the Q&A panel, and we'll respond back to you. But while we are getting the questions, a couple of quick reminders. This webinar is being recorded, and all the registered participants will receive a copy of the slide deck that was just presented, and also a recording, the link to the webinar recording, so you can you can review that. And I know there could be a few questions which are which need additional details, or where we need more clarity into the context of what questions are being asked. So anything that we are not able to answer, I would certainly encourage you guys to go ahead and open Ask an Expert request. So I'm sure you would have done that in the past. When you go to the eSupport portal on the case management, one of the options is to go ahead and open Ask an Expert. So you can choose MDM and request for any clarifications or suggestions on. So that will give you like a dedicated 45-minute time with subject matter experts to answer all your questions. In the meanwhile, if you have any questions, we are open for it. So please go ahead and ask your questions on the Q&A panel. So I think, Jim, thanks a lot for the appreciation. So I think there's one question which says, which tuning tips give the best results overall, or at least where do we start? Is that something that we can have a generic answer for you?
It all depends, right? I mean, is it specific to real-time performance, or is it specific to batch performance? So it's hard. I mean, I would say one thing that will affect both real-time and batch is the Infinispan config setup. So the Infinispan cache has to be set up properly. One thing I can show you probably is, we spoke about the DB filtered rules, how we can I'll show you how a filtered rule can be created. Okay, my instance is giving me problems.
Souvik, you're asking for a KB article. I don't know which specific KB article are you requesting for which topic?
Best practices in HMDM, hosted MDM.
Best practices in hosted MDM.
So that I think we would need an Ask an Expert session to walk them through what best practices have been followed.
Correct. Yeah, I think we will. I know there are a lot of questions coming for the hosted MDM side of things. We probably will have a separate webinar just for the hosted MDM side of things. So please keep an eye on that. There's another question: why restart an MDM application server takes? Can we do some workaround? I think I mean, performance questions are, I don't know if it's very simple and straightforward to answer as part of a Q&A session. We probably need more troubleshooting and understanding of why it takes some time.
Job repository.
There's a question from John. When are you going to support the creation of custom indexes that use include columns?
We do have support for custom indexes. Unless you're talking about functional indexes. The only index that is supported is the case sensitive index right now.
I think we'll need to get more clarity from the product management to answer any of those feature request questions. So we'll get back to you on that, John.
Yeah.
There's one question from Jignasa. I think it's about a parameter will only control the display of batch job data, and will it also perform delete operations on C-report job control?
No, CMX server job control number of days only controls the display of the jobs on your console. It will not delete the jobs.
QP has been updated today.
I believe somebody asked to look at these job control tables.
The repos table.
Was it this one or the other slide?
Can you review the repos table slide?